Okay, next we're going to do this example, and it's an example where we can use the power rule. It says the temperature, capital T, in degrees Fahrenheit of a person during an illness can be modeled by the equation capital T equals negative 0.0375 T squared plus 0.3 T plus 100.4, where T is the time in hours since the person started to show signs of a fever. Part A says find the value of capital T when little t equals 2 and interpret. And this word interpret simply means write a sentence and include the units of the numbers in the problem. All right, so t when little t is 2 simply means evaluate this function when little t is 2. So we'll put a 2 where each t is, and we will evaluate that. And when we put that into the function, you should get this following number, 100.55. All right, now let's go ahead and find dt over dt. So that's d capital T over d little t when t equals 2. And then we'll interpret both at the same time. All right, now what does this notation right here mean? That simply means the derivative. D capital T over D little t means the same thing as T prime. It's the derivative. So let's find our derivative using the power rule. Negative 0.0375, need another 0 there, there we go, times the derivative of t squared, which is 2t, plus the derivative of 0.3t, which is 0.3, and the derivative of a number by itself, which is 0. All right, so if we simplify that really quickly, we should have negative 0.075t plus 0.3. And what we want to do now is let little t equal 2. We're going to put a 2 right there. So we're going to find t prime of 2, negative 0.075 times 2 plus 0.3. All right, so I'm going to go over here to my calculator. I'm going to find that number. And what I get is 0.15. Now, what does this and this mean? Okay, well notice the 2. The 2 is a little t. And little t is the time in hours since the person started to show a sign of fever. So for our interpret, we'll say after 2 hours, the person's temperature was this number right here, 100.55 degrees Fahrenheit. And this number right here represents a rate of change. Rate of change. That's what this notation means, rate of change. And so the temperature was increasing by 0.15 degrees Fahrenheit per hour. That's because D capital T, that's the first thing, that's degrees Fahrenheit, comes first. Per hour, hour comes second. That's the very nice thing about this notation right here. Degrees Fahrenheit per hour. That gives us the units for that number right there.